China and Russia are up to something big on the moon. In order to facilitate multidisciplinary scientific research and long-term autonomous operations on the moon's surface or orbit, China's CNSA and Russia's Roscosmos are working together to build the International Lunar Research Station, a planned lunar outpost. The project's goal is to provide a comprehensive experimental laboratory for lunar exploration, observation, and technological verification. It is anticipated that construction will commence after 2028, and use will begin in 2036. The ILRS, which is accessible to partners worldwide, is a significant advancement in lunar exploration and collaboration. Number 7. Joint construction of a nuclear power plant on the moon. One of the most ambitious and technically difficult space projects ever imagined is China and Russia's determination to work together to build a nuclear power plant on the moon. This project is part of their larger International Lunar Research Station program, which intends to create a long-term sustainable presence on the lunar surface. The program focuses on the south pole of the moon because of its special environmental benefits, which include almost constant sunlight and possible water ice deposits. During its initial deployment and operation, the nuclear power plant is intended to be an automated facility that requires little human interaction. Russia brings to the table decades of experience with nuclear reactors in space, particularly the Topaz reactors, which were created during the Cold War and tested extensively on Earth. These reactors were intended to generate electricity for spacecraft. Number 6. Powering the International Lunar Research Station. The main purpose of the nuclear power plant will be to provide the ILRS, a joint China-Russia lunar outpost intended to support a broad range of scientific, technological, and exploratory operations with steady, uninterrupted electricity. With the possibility for water ice formations in permanently shaded craters and near constant sunlight on raised plateaus, which is beneficial for solar power generation, the ILRS is slated to be situated toward the moon's south pole, an area of great interest. However, solar power alone is unreliable for continuous operations due to the harsh lunar environment, where temperatures range from minus 173 degrees Celsius at night to 127 degrees Celsius during the day, and the lengthy lunar nights, which span roughly 14 Earth days. Life support systems, habitat heating, communication arrays, research instruments, and robotic explorers will all depend on the nuclear reactor's constant power supply. With the help of this energy backbone, the ILRS will be able to support long robotic missions at first. Number 5. Autonomous construction without human presence. The idea of building and commissioning the China-Russia lunar nuclear power plant independently, without the need for astronauts to be physically present on the moon during the early stages, is an impressive feature of the project. This strategy lowers mission risk and cost by utilizing advanced robots, artificial intelligence, and remote operating technology. Robotic landers and automated systems like the SMENA series of lunar landers, which are made to deploy equipment, lay cables, and assemble modular components on the lunar surface, will assemble the nuclear plant and the ILRS infrastructure, Roscosmos Director Yuri Borisov said. These robots will carry out intricate activities, including site preparation, module assembly, and system integration, while being remotely supervised from Earth or from orbit around the moon. The risks associated with the moon's hostile environment, such as radiation exposure, micrometeorite impacts, and sharp temperature fluctuations, which make early human presence dangerous, are lessened by autonomous building. Additionally, this plan enables the base to be self-sufficient and operational before to astronaut deployment, guaranteeing that vital systems are tested and working. Number 4. Timeline and missions. The sequence of China's Chang'e lunar missions, which act as forerunners and foundational work for the base, is closely tied to the timeframe for the ILRs and the nuclear power plant. Launched in 2024, Chang'e 6 successfully returned samples from the south pole of the moon, showcasing China's sample return capabilities and yielding priceless geological data. In-depth investigations of the South Pole region including as mapping water ice formations, evaluating terrain, and testing in situ resource utilization technologies, are planned for Chang'e 7, which is scheduled to launch in 2026. The crucial Chang'e 8 mission, which is slated for 2028, will test technology for the ILRS, such as robotic building methods and maybe crewed operations. It will also be the first time China sends astronauts to the lunar surface. Number 3. International collaboration and geopolitical implications. The ILRS project involves a coalition of 17 nations, including Egypt, Pakistan, Venezuela, Thailand, and South Africa, and goes beyond a bilateral China-Russia collaboration. A deliberate geopolitical attempt to develop a different framework for lunar exploration in opposition to the US-led Artemis mission is shown in the wide international participation. Despite delays and financial limitations, Artemis, led by NASA and its Western allies, intends to build a lunar gateway and surface base by the late 2020s. With a varied membership, the China-Russia-led ILRS aims to create a multipolar space governance paradigm and promote collaboration among emerging space nations. In addition to strengthening scientific cooperation, this alliance acts as a geopolitical check on Western hegemony in resource extraction and space exploration. International conventions and treaties governing space activities may change as a result of the ILRS's inclusive strategy, which seeks to democratize access to lunar science and technology. In the larger framework of global power dynamics, this changing environment emphasizes the growing significance of lunar resources, strategic location, and technological leadership. Number 2. Technological and scientific goals. The goal of the ILRS and its nuclear power plant is to advance space technology and science. Understanding the moon's genesis and evolution will be made possible by the station's ability to serve as a flexible platform for basic study on lunar geology, environment, and radiation. Long-duration autonomous activities, such as robotic surface vehicles that can carry freight and carry out exploration over long distances, will be tested technologically at the ILRS. In order to facilitate activities on the lunar surface and in orbit, it will also create and implement cutting-edge communication and navigation systems. In order to provide redundancy and flexibility, the power infrastructure will be hybrid, integrating nuclear, solar, and radioisotope generators. In order to support a sustainable human presence, scientific investigations will concentrate on in situ resource utilization, which includes processes like harvesting water ice and generating fuel and oxygen. To validate radiation shielding, temperature control, and air recycling systems, life support and habitat technologies will undergo extensive testing. When taken as a whole, these initiatives will produce crucial data and operational expertise that will support upcoming crewed missions to Mars and other deep space locations, establishing the ILRS as a crucial first step toward humanity's interplanetary aspirations. Number 1. Strategic space partnership between China and Russia. The nuclear power plant project is a prime example of China and Russia's growing strategic partnership in space exploration, which challenges the conventional Western-led space paradigm by combining complementary strengths. The Topaz reactors and continued research on nuclear propulsion and power systems for spacecraft, orbit, and the moon are examples of Russia's decades of experience in nuclear space power. Conversely, China contributes significant financial resources, a quickly developing lunar exploration program, and strong launch capabilities with its heavy-lift Long March rockets. The partnership also emphasizes the growing militarization and strategic significance of space, since nuclear power on the moon might support future defense-related capabilities, in addition to commercial and scientific endeavors. In conclusion, the goal of China and Russia's lunar cooperation is to construct a permanent nuclear-powered lunar facility by the middle of the 1930s. This base will act as a center for scientific study and provide a new geopolitical foothold on the moon. If you liked our video, Please hit the like button and subscribe to our YouTube channel.